third problem. Let us try to solve the problem number 3 according to the problem number 3, which is already given into your PDF file, and also you can go through that question. Just try to read out the question and we'll try to solve it. The question which is given is 90 kilojoules of heat is applied to a system at constant volume. The system rejects 95 kilojoules of heat at constant pressure and 18 kilojoules of work is being done on it. The system is brought to the original state by adiabatic process. Determine the adiabatic work, the values of internal energy at all end states if the initial value was 105 kilojoules. Okay, let us try to understand this question and then we will try to calculate. Here the question been asked, this question is asked in January 2012, 5 marks question. So for this, let us try to draw the PV diagram first and let us understand this and we'll try to solve the problem according to this. What has been asked is adiabatic work as well as the internal energy at all end states. So according to this question, let us draw the PV diagram. So for this PV diagram, the initial state which is given is been at constant volume. So let us take this, the first process from A to B. Let us take this as constant volume 1. Okay, let us mark this as A to B as a constant for the state 1 for the process constant volume. And the next thing which is given is, the second one which is given is a process, isobaric process, where your pressure is constant. This V is equal to C and P is equal to C. Let us mark this point as C. And another one is, which has been asked, another one is the last process which is brought back to that initial state is by adiabatic process. Okay, so this is PV power gamma is equal to constant adiabatic process. So in this, first the case which is given is 90 kilojoules of heat is applied to the system. So here the heat is being supplied in and the next is 95 kilojoules. This is 90 kilojoules. And next is, in the second one is 95 kilojoules of heat has been rejected. So here heat is out. This is 95 kilojoules. Okay. So in the second case, the given data is at state 1. If I take that state 1, the heat which is given is Q12, which is given as 95 kilojoules, which has been added. So this sign is positive. And next, other thing which is given is at state 2, that is 2-3, state is given as 95 kilojoules, which minus because the heat has been rejected, and also at state 2 work is given. State 2 work is given, that is 18 kilojoules. And also internal energy which is given, that is initial value. This is at state 1. U1 is given as 105 kilojoules. Okay. Anything else, the data which is given in this case? Right. So this is the thing. These are the data which is given at the state 1 and state 2. At state 3, the properties has been brought to initial state. Brought to initial state adiabatic process. Okay. So what is we need to find? To find the work, adiabatic work, and next is, this is adiabatic, and next is U at all end its states. That is U1 is known, U2 that is UA is given, UB is you need to calculate, UC is you need to calculate, UB and UC. According to this UB, UC is we need to calculate. Okay. So let us start with the case 1. The case 1 which is the process which is from A to B. A to B process. So in this, let us try to apply the first law, that is d dash q is equal to d dash w plus du. As this being a constant volume process, so as you know, in the constant volume process your d dash w will be 0. So finally we write d dash q is equal to du, it is equal to u2 minus u1. Okay, so d dash, that is q, which is for the 1 2, that is AB is given as 90. So let us take this, 90 is equal to u2 minus u1 is given as 105. So finally we get u2 as 90 plus 105, that would be 195 the value. Okay, next again at value which is for your B to C process. B to C process. For B to C process it is isobaric process. So let us apply the isobaric process where d dash q is equal to d dash w plus du. For isobaric process, as you know, for where it is enthalpy change H2 minus H1. Okay, but thing is here which you are calculating this, work is already given. Work is already given here. Work is already given. That is, as you know, and also heat is also given. Heat is also given. So heat from this is minus 95 is equal to the work which is being given over here from B to C, that is 18 kilojoules. Okay, plus U2, that is U2 in this UB or UC minus UP. Okay, so in this case already you know UB value. Okay, so let us try to calculate the finally U3 minus 2, that is UB will which is already you have got this, so UC will try to calculate. UC is equal to minus 95, and also another important thing is it is minus. Why it is minus? Because the work is done on it. Work is done on it. So you get it as plus 18. So, and also you know UB, it is minus over here, then you get plus over here, plus what is it? 195. So finally I got this value as UC as 118. 118 kilojoules internal energy. Okay. Next, the process B to C, that is this UB is known. From this we have calculated UB and we have calculated UC both. And next is what we need to calculate is the adiabatic work. So to calculate adiabatic work, how do we calculate your adiabatic work? To calculate the adiabatic work, just integrate the cyclic integral of your work is equal to cyclic integral of heat transfer. That is cyclic integral of d dash w is equal to cyclic integral of d dash q. So from this we can calculate your adiabatic work. So for this adiabatic work, why actually we are calculating in this way, why we are not going with the first law is because suppose if we go with this adiabatic work, if I try to apply the first law over here where the work is not known and where your heat transfer will be 0 and your internal energy is not known. If you want to calculate your work over here, this heat transfer becomes 0, but the case of your internal energy for the state of this thing, so that's the case we go with your cyclic integral by applying the d dash w is equal to d dash q. So for this d dash w, what is it? Work from AB plus work from BC plus work from CA is equal to Q of AB plus Q of BC plus Q of CA. So in this, as you know, Work of A, what is we are actually calculating? Work of CA, that is adiabatic work we are trying to calculate. What is work of AB? Work of AB, which is already we have 0 because it is constant volume process. Work of AB is 0 because it is constant volume process, and work of BC is already given in the question. Okay, and work of CA we are going to calculate, and Q of AB is already given, and Q of BC is already given. Q of CA is 0 because adiabatic. So finally, if you substitute these values, which is what is this is minus 18 plus CA is equal to QAB is 90, and this cube is minus 95. So finally, I get WCA as which I got as 13 kilojoules. So this is a value which I got. Okay. So in this case, which is asked for 5 marks, PV diagram carries 1 mark, and internal energy which carries another mark, and internal energy at the state 1 carries another mark. 3 work which is calculation the adiabatic process work is 4 marks, and all the formulas which carries another 1 mark. Okay, totally 5 marks. I hope this solution is clear. For the next solution, that is question number 4, we'll solve it in the next session. Okay, thank you.